My name is Ahora Shifra, and these are my personal details: my name, my student number, registration number, and I'm a software engineer year 2 at Makerere University. So now I'm going to start with the problems that we face in some of the problems. Okay, we are supposed to talk about a problem we have identified in our community and then explain how it affects our community, and then talk about how AI can be applied to solve that problem. So I have discovered, or I have tried to observe, that health complications are so many in the community. The community has faced a big problem of very many deadly diseases. Some of these diseases may kill people in no time. For example, Ebola, we witnessed COVID, and others may slowly grow within a person and later cause health complications or even death. For example, heart diseases, pneumonia, cancer. So those are the diseases. So now the impact of these diseases to the community. Most of these diseases have claimed lives of many citizens, and this has led to loss of great leaders, which leaves some of the important posts in the community vacant. Then diseases, for example, Ebola, they spread over a wide range in a short time, and this causes terror among citizens. This may hinder many activities, for example, trade, moving from one place to another, and it puts most of the activities on a standstill. Then we have cancer. Cancer is a common disease, and it has led to anxiety, distress, and depression when one gets to know that cancer is up in their body. And this may lead to poor performances at home, at work, at school. And that is all about the impact of these diseases to our community. So now I'm going to explain how AI can be applied in order to solve the spread of these diseases and how to control them, at least let them be on a small pace. So artificial intelligence can be applied by developing a model. That's what I'm thinking as me. So this is how my project is going to be: developing a model that can easily detect a disease at its youngest stage before it attacks any other body part, and can help suggest the exact medical attention one needs to protect oneself from such a disease. So this system can also predict a drug treatment results. For example, with cancer, you can be given the same medication. Like, you can get patients and they're given the same medication, and then you try to monitor them and see which patients live and which patients die. If many patients have lived with that sample that you have tried to test with, then that system can easily predict the drug treatment results. If many patients live and then few die, meaning this drug can easily be used to treat cancer, and vice versa. So we have different types of machine learning. We have supervised and unsupervised learning. So the main difference between supervised and unsupervised learning, it's all about labeling of data. So with supervised learning, data is labeled to inform the machine about the exact patterns it should look for. It also involves classification of different file types, such as images or text. Okay, with supervised learning, the machine is told to first feed in data into the machine for it to know the outcome, for it to predict the outcome that you would want. And then with unsupervised learning, it has no data labels. The machine looks for the patterns randomly and is more of hands-off approach. It doesn't need any much supervision from human labor. And for it, the machine develops its own labels as it continues to do its work. So now we have supervised learning techniques, and the main ones are regression and classification. So regression estimates the relationship between independent variables, and for this system, one may input his age. For this system model that I'm trying to develop, one may put in his age, how often he suffers from random illnesses like flu, and the system can tell if the person is prone to a particular disease. And then this system can also read and understand the functioning of one's body organs, I think through like X-rays That means you feed in the images of your X-rays, and this system can be able to tell which body part is likely to suffer from a certain disease by studying how your body organ is functioning. So that is with regression. Then with classification. Classification is when the output is categorized, for example, like the output is categorized into one whole thing. For example, when this system, you put all your details, your age, it studies your features of this human being, then it can easily tell if this person is male or female. So that's it with classification. And then now we go to unsupervised learning techniques. There are two main types of unsupervised learning techniques, which are clustering and association. Clustering processes the data and finds natural groups according to their similarities, characteristics, and even differences if they exist in the data. And then association allows to establish relationships amongst data objects in large databases. For example, with this system, when it reads that one has exclusive stomach pains, it can easily tell that one is likely to suffer from others. Now, for example, association, for it creates a relationship between the data objects. So it can easily tell that with these signs, this can happen. So it creates that relationship between those. Now for this system, it can tell that, okay, if someone has put in how the signs have been, like feeling stomach pains or, with all those things, after reading all that in form of text as one person has input, then it can easily tell that this person is likely to suffer from like ulcers with this system. Then the technical challenges that are likely to be affected by this system. The first thing will be all about data scarcity. So now, as we can see, many people are so vigilant with giving out their data to anyone. And we have said that this system will need data to be input for it to know exactly what to output. So if someone puts the wrong information or does not give the utmost information or utmost data that is needed to be fed to the system, so it can easily predict the wrong information or it cannot bring out the exact output that is supposed to be brought out. So then we are talking about the computer. Another challenge will be computing power. So such artificial intelligence systems require an ever-increasing number of cores and a super computing power, which is so expensive. And this is because this system will be studying some complex human structures and organs, and it will need a high computing power for it to give out the exact output. And then we have data privacy and insecurity. So this data is generated from millions of users, and in case of a cyber attack, the personal data that belongs to all these people might be exposed to others. And this data may include medical history and problems, diseases, and even much more. And then we have, suggesting some possible solutions that can be followed to solve these problems. We have isolating sensitive data and ensuring that it is accessible to a particular system that needs to be accessed. And this can easily curb the problem of data privacy and insecurity. Okay, this is where you specialize in that data that is not supposed to be known by everyone is kept in a particular system, and only that system that needs to know much about that data is exposed to it, so that insecurity of data can be curbed and stopped. So now we have differences between accuracy, recall, precision, and FI score. So accuracy tells how many times the model was correct, and all in all, it is the ratio of the correctly predicted classifications. That means that both true positives and true negatives to the total test data set. So if you had the true positives and the true negatives, accuracy is equal to the ratio. Okay, it's the same as the ratio of both true positives and true negatives divided by the total test data set. Then precision is how good the system model is at predicting a specific category. So precision is the ratio of the system generated results that correctly predicted positive observation. That means they are the true positives to the system's total predicted positive observations. That means they are both the true positives and the incorrect false positives. Then we have recall. Recall tells you how many times the system model was able to detect a specific category. So recall is the ratio of the system's generated results that correctly predicted positive observations, those are the true positives, to all observations in the positive class, meaning the actual positives and the other false positives. So that is how we predict the recall. And then the F1 score is the weighted average of the precision and recall. So this one, it takes both false positives and false negatives into account to get a balance between precision and recall. So now my system is able, it will take as its metric evaluation to be able to have a better accuracy and a better precision. So with the accuracy, taking an example of like cancer, when the drug treatment results are positive, that means many patients have healed from that drug that they were trying to test. For example, when we used a sample of like 20 people, if 17 heal and 3 die, giving it a high accuracy of 85%, meaning the system is highly accurate. So with precision, this model system should be able to study the data input, for example, the age, then study one's X-rays images of his body organs, and it should be able to predict the disease one is likely to suffer from. And it could also even prescribe exact drugs to be taken based on the drug treatment results from specific diseases. So that is all. And this last slide has some of the references where this information can be gotten and where I tried to research from to get this whole information. Thank you for listening. I'm Ahura Shifra, software student, second year at Makerere University.